We have a problem. And this isn't just a singular issue with clear steps to a simple solution. It's a multi-layered conundrum. We are told that renewable energies are the solution and that fossil fuels must be phased out. Now tell me if this sounds familiar. The world is heating up and we are to blame. And a third of the world's greenhouse gas emissions come from the transportation industry alone. So, the one-size-fits-all simple solution that has been fed to us is electric vehicles. But do any of us really know where our electricity really comes from? Or where these batteries are made and where they go after they die? We are told that electric vehicles are the solution, and yet those very electric vehicles use minerals that are mined in third world countries that employ child labor in unsafe working conditions. But let's just pretend that that isn't an issue. Oh, yeah, we still need to address the big oil companies that lobby parliaments to allow them to continue their search for oil and silence those who speak out against them. This is what I first thought intuitively from the comfort of my coal-powered AC room. And like many others, my next thought was, surely electric vehicles have to be the solution. But it's not that simple. Unfortunately, it's in our nature to jump to easy solutions for big problems. And that's our real problem. And I should know, because that's exactly what I did. Let me tell you my story. Ever since I was small, I've always wanted to know how things work the way they do. And as a consequence, my parents were constantly bombarded with the question, but why? But why, but why, but why, but why? And as I got older, I was given Legos and encouraged to tinker with anything that wasn't bolted down to the ground. Then we came to Green School, where I was introduced to this beautiful campus and given a fresh perspective on how amazing nature really is. I was in and out of the rice fields every day, coming home covered head to toe in mud and getting an earful from my mother for ruining yet another fresh white shirt. But as the years went by, and I got to 8th grade and learned how if we did nothing to slow the effects of climate change, we would lose our one special place in this universe. And so, I knew whatever it was I was going to do for my Greenstone, was going to be not only hands-on and technical, but something to hopefully slow or undo the harm that was caused by us. Fast forwarding again, and I'm now in 11th grade. And I'm kind of thinking about Greenstone, but I'm more thinking about how I can convince my parents to let me get a motorbike, so I can tinker with it and ride it around. And then it hits me. Back in middle school, we did an experiment with Pack-Ollie, where we turned water into HHO. And when this gas came in contact with the flame, it would explode. So the gears started turning, and I put the pieces together. I could make this magical gas, I could get the bike I wanted, get it to run on it, and it would be super fun. I'd get to play with fire. It'll be easy, right? Boy, did I not know the world I was stepping into. The world of research and testing and countless fake videos. In my excitement, I would peruse the internet for hours on end, looking for any video explaining what, why, and how amazing HHO was and how it helped engines. Then I would find another video, this time from all the way in 2008, with video quality so poor the camera might as well have been a potato. But nonetheless, I eagerly watched it, seeing some kid in his mother's backyard hooking up his very own HHO generator to a lawnmower and running it solely off of hydrogen. It filled me with excitement, seeing so much information feeding me with the idea that this project was going to be relatively easy and manageable. But let's move away from the potato and talk about HHO and energy. Why are we so dependent on fossil fuels? The answer is energy. But how do we actively get enough energy? And I'm talking in all forms, to power our transportation, our lights, our heating, and just about anything else you can think of. Currently, most of that energy is generated Currently, most of that energy is generated and used on demand, stemming from highly calorically dense materials. And yes, I am talking about those kind of calories, but you definitely shouldn't eat these following things, because I'm talking about coal, biogas, and fossil fuels. But what about green alternatives, I hear you all asking? The issue with a lot of green technologies is that they're not always available. Solar stops producing energy once the sun sets, and wind power only works when you have a constant, strong breeze. We don't have enough energy to sustain ourselves as is, let alone to mention the growing energy demands of AI, emerging technologies, and growing world populations in developing nations. But what if we could save energy for later? Imagine you get a surprisingly sunny day, and your energy requirements are met. You could take that excess energy and store it electrically in a battery, thermally in a sand battery, or even chemically as hydrogen. And using a similar system to the one I built, you could take that excess energy and store it in bottles. This is much greener and a much better way of storing energy than that of a battery. And this is because the materials used for these kind of projects require a lot less processing than that of lithium. Not to mention, you could then use this energy directly to power your car, heating, cooking, or even turn it back into electricity later. Now, wouldn't that be awesome? But unfortunately, what we are doing as a society now is not the solution. But that's not to say that there isn't a solution. And by demonstrating that hydrogen-enhanced combustion can improve fuel efficiency, I'm proving that practical solutions to climate change exist beyond the options that we are currently being offered. By a show of hands, before today, who has heard of an HHO system before? Ooh, surprising. Well, my idea isn't unique. I'm not the first to think of it. In fact, plenty of other companies are already doing it. HHO hybrid engines can be a stepping stone to achieving a net zero future, and companies like Hyundai, Honda, and Toyota are already doing it and believe that it is the future as well. We all know what EVs are, but I would feel confident in my guess, assuming that not many of you know that there are cars such as the 2026 Toyota Mirai. This car is classified as an FCEV, and it takes stored onboard hydrogen to turn into electricity, which then in turn powers the car. Bonus, the only emission is water. All of this to show you that there are other alternatives than that of EVs or a strictly bicycle-only future. So let me show you what I've been up to these past 2 years. I started by pitching my ideas to my parents and family abroad and starting a GoFundMe. And soon after, I had family and friends donating to my project, and I managed to raise over 800 euros. From there, I built my very first HHO generator. My little proof of concept, made out of nothing more than a couple of rusty screws I found laying on the floor and a jar from Kumbali. The result? Although it was slow, it produced hydrogen. And from that moment, I knew I could do this. So I ran a couple more tests and noted down some observations. It turned green, got really hot, and it still wasn't making enough hydrogen. So, with these questions in mind, I went back to doing research and came up with version 2. Version 2 was essentially just a bigger version 1, because I thought that logically, if I just make the whole thing bigger, surely the amount of hydrogen I get will also be more. But when I tested it, it really wasn't that great. The cell only produced 65 milliliters of hydrogen per minute, and I really wanted to achieve the goal of 1 liter per minute. Not only that, but the cell was also plagued with the same issues as the first version. It got really hot and still turned green. So I went on to version 3, that one right here, this one right here, which was practically the same, and so I will not talk about it. So back to doing research, and I found out about dry cells. The crucial difference between a dry cell and versions 1 through 3 is whether the wires that power the machine are submerged or not. And after looking further into the design of dry cells, by stacking the plates something like this. Okay, I've lost myself now. Oh, okay, I just got the whole thing switched up. I'm not missing a slide, we're all good. After looking further into the design of dry cells, this guy, along with the research paper, suggested that instead of using stainless steel, I could use graphite foil. The paper that the man cited tested out several different materials, including EN8, 316L stainless steel, and carbon. And supposedly, from all of these tests, graphite foil was the most efficient. So I thought this was quite promising, and for my next design, version 4, not only would it be a completely different design, but it was also going to use graphite. Unlike previous designs, by stacking the plates like so, the entire surface area of each plate would be working to make hydrogen and reducing the amount of energy wasted as heat. Now, I thought that this design was going to absolutely destroy all the previous versions I had made. Not only had I addressed the heating issue and found the best layout for the cell, but I was also using graphite foil, the supposed best material for this project. So I eagerly plugged it in. Nothing happened. I turned it off and on again, and still nothing. Good God. So I went back to doing research. Oh no. Seeing this massive failure on my hands, I went on to version 5. This model took advantage of everything I had learned so far from previous designs and all the papers I had read. It's made out of stainless steel 316L, 3mm rubber, and acrylic. And the words in my mouth don't come out. And the geometry of the cell was also changed to try and optimize the flow of hydrogen. So this time, I plugged it in. And I was generating, on the very first test, 200 milliliters of hydrogen per minute. This absolutely destroyed everything I had done so far. And needless to say, I was excited. But I wasn't done yet. I spent a lot of time in the iHub. And I mean a lot of time in the iHub, constantly testing and rebuilding version 5 as problems kept coming up. First, the cells were short-circuiting, then there were leaks, and the gas kept getting stuck in the pipes. And the most infuriating part of this all would be the amount of times I had to replace and rebuild that stupid glass jar. Rebuild the glass jar, as it would constantly crack or leak. Looking back, who would have thought that bringing a glass jar with a bunch of other really heavy stuff to and from school on the back of a motorbike would end well? Well thought, well thought. But anyway, I want to tell you the story of the most memorable time that jar broke. I remember once I was in the middle of resetting a test where I had to disconnect the tank from the cell so I could clean it out. While pulling at the very last pipe connecting the tank to the cell, I forgot one simple rule. Always hold the glass tank, and it fell and cracked on the table right in front of me. Not even 30 minutes earlier had I finally gotten it to stop leaking from microscopic cracks, and now there was one giant one staring me in the face, mocking me for my stupidity. So I tweaked and rebuilt version 5 countless times. And now, today, this is what version 5.9999999999999 looks like today. The only difference between version 5.9999 and the original version 5 is that I not only built an integrated reservoir, streamlined connection terminals, but also added larger pipes to hopefully prevent the whole system from breaking and leaking. Spoiler, it still leaks. But anyway, after all of those modifications, I tested version 5.9. And I was making over 1 liter of hydrogen per minute. I successfully met my goal, but not only that, at peak efficiency, the cell was generating 4 milliliters of hydrogen per watt of power. And I know that might sound a little bit technical and nerdy, but that's the difference between a science experiment and an accidental kettle. So now here comes the boring part, but I would hope that you're all curious as to how any of this actually works. You all know what the molecular structure of water is. My machine takes 2 of those molecules and splits them up using electricity, using a process called electrolysis. And this is just a fancy way of saying I'm electrocuting the ever-living shit out of the water. The now broken up molecules reform themselves into 2H2 and O2. These gases then come out and are extremely volatile, and the excess oxygen could help a fire burn hotter and brighter. So now we have HHO, and what we do with this is we take it and we put it on the intake of an engine, so that when the engine reaches its intake phase of its on the cycle, not only will it pull in fuel and air, but it will also pull in a little bit extra fuel and a little bit extra oxygen that comes from our HHO. The logic behind this is because of the characteristics of hydrogen fires. Hydrogen has a relatively higher flame speed than that of petrol, at around 3 meters per second. And this, along with the extra oxygen, makes sure that every single drop of fuel present in the cylinder gets fully and completely burned, resulting in more power coming out of the same amount of petrol and less energy being wasted. And we haven't broken any rules of physics either. This is because before introducing HHO, the engine doesn't fully and completely burn the petrol, resulting in wasted energy and unburnt hydrocarbons coming out the exhaust. And these gases are a lot worse for the environment than just regular CO2. So, by using the gas, not only do we get more energy out, but we also reduce the amount of harmful gases coming out the exhaust. But did I actually manage to do that? Well, 4 days ago, I was setting up to do my very first hybrid fuel test. I had all the equipment ready, everything connected, measurements prepared, and camera set up. This was the moment I had been waiting for and working towards over these past 2 years. And needless to say, I was very excited. So I grabbed the start cord and I pull it. Boom! It exploded right in my face. The blast launched part of the engine across the room and destroyed several components, and instantly ended the test before I could collect any meaningful data. Safe to say, that was not part of the plan. But honestly, it did suck. I was incredibly excited to show you all today a fully functioning prototype with real test results, but instead, I ended up with a partially destroyed engine and a very long cleanup. And nobody is more frustrated about this than I am. But that's engineering. You test, you fail, and you rebuild. And then you figure out why you failed in the first place. And sometimes progress looks less like a breakthrough and more like accidentally creating a pipe bomb in the iHub. Nobody saw that. That was for the end. And honestly, moments like this kept happening throughout my project. Since the start of this project, I was super ambitious, but also a little bit naive. And I wanted to magically make engines more efficient. And I thought I could do that by just attaching the system to the vehicle's battery. But if any of you paid attention in physics class, you would know that energy cannot be created or destroyed. It can only change its form. And I, for whatever reason, thought that was really stupid and decided that ignoring it was going to make my life so much easier. It didn't. And now I had to figure out a way of powering my system with something other than a battery, or change the direction of my project. And I really didn't like that idea. As with any project I do, I set goals internally for myself. And if, for whatever reason, I can't meet those goals, I think that I have failed. And as for this project, I had already said how much I hated the idea of big, bulky batteries powering things, as not only were they taxing to produce, but they weren't accessible to everyone. Yet it seemed like it was the only solution. This is where the first mental breakdown of my project started. And I didn't know if my project was even possible anymore. I would be kept awake at night by thoughts of, am I a fraud who's made claims about something he didn't know enough about? And if I really liked science and engineering, I would have known better, worked harder, and done more research. I'm not fit to be an engineer. But then I realized that there were other ways of getting energy. I could use solar powers or systems like regenerative braking to power the system. And eventually, I got over it and redefined what I wanted to achieve with my Greenstone. I realized that the heart of my project was really just proving that that hydrogen can improve fuel efficiency in vehicles and could be a viable solution, one that I wanted to pursue to having an effect on climate change and reaching a net zero future. Now, there's a lot of this project that I couldn't talk about today due to this project being so much bigger than I originally anticipated. And so I've had to skip over many of the other amazing but also really annoying things that happened throughout this project. But know that I've had to dunk my head into several different worlds of engineering to make this project happen. And looking back, this project kind of feels like something you would do postgraduate with a whole team of people and not a single high school student should do on their own while juggling APs and the rest of their alma. But nevertheless, I am proud of what I've managed to accomplish. And just to give you an idea of what I didn't know at the start of this project, I now know how to create circuits, manage large projects, fundraise, and do postgraduate levels of research, and so much more. And although I don't have the final prototype I wanted today to share with you all, I have learned so much and had to do it pretty much all alone. Now, if there's one thing you take away from my nerdy blabbering, it's that I hope I have inspired you to take something you love, whatever it may be, and use it in some capacity to make the change in the world that you want to see and that we all so desperately need. Take, for example, all of the amazing work my peers have been doing over these 2 years as well and have presented to you over these past 2 days. If a bunch of high schoolers can do it, why can't we all do it? I've realized that this is what I want to do. I want to try and fail again, just to realize that this one tiny part of the puzzle I was missing was the one piece I needed. To find the piece, we must screw down to fix this massive screw up. Thank you. Now, before I leave, I would just like to say my thank yous. I would like to say thank you to everyone who supported me along my journey and my crash outs. To my parents for always being there and always giving me a healthy dose of reality when I needed it, but never once doubting me, most of the time. To my second home, the iHub, and for giving me the opportunity to always work there and build my crazy ideas, for giving me all the scars and cuts and burns that I can look back on with pride. To Ibu Mega, Ibu Andina, Ibu Rai, and Pakezar, the amazing people who keep the place running and try their best to stop me from getting those said cuts, scars, and burns. Yeah, this project could not have gotten anywhere as close to this without them. So if we could give them another big round of applause. Stand up, take a bow. Yeah. Thank you again so much. To my teachers, Pak Ram, Pak Jeff, Pak Brian, and Ibu Jeff, and Ibu Kate, and Pak Benjamin, and I can't remember everyone's names right now, but all of you have pushed me and believed in me and supported me every step throughout this process, and I would not be standing here with nearly as much confidence as I do today if it wasn't for you. So thank you. And now finally, to each and every one of my friends who are scattered throughout this place, and some of you are online, thank you for always being there, even when I was losing my brain and going insane and ranting out about how this project was impossible one day and really doable the next. Thank you. Thank you.